Hey guys, my name's Will. I'm the CEO of Firehawk Aerospace. I think we have a video that we can play real quick. Before we press play, I want to let you know I am holding 3D printed rocket fuel. So what Firehawk does is we 3D print rocket fuel, and the reason why we 3D print rocket fuel is it's allowed us to take a process that traditionally takes 15 to 60 days to produce rocket fuel for our defensive systems and cut it down to just about 7 hours. Not only is it 7 hours, but we can do it almost anywhere. We can do it on the edge. So right now at our test site where you're about to see, we actually have our solid propellant factory out there producing rocket fuel. So a much bigger version of this powered this motor. So if you want to press play, you can see what this is capable of. Maybe. So just a 10-second test of about 1,000 pound thrust of rocket motors. Similar to like a guided multiple launch rocket system, a little bit smaller than that, but Firehawk's been able to grow pretty exponentially over the years because the way we produce rocket engines today, the way we make our rocket fuel today, it's two companies, and they've been doing it the same way for decades. They have massive planetary mixers, which is, these 1,600-gallon mixers where there are only three of them in the United States. They're hidden in the mountains of Utah. They dump all the ingredients into these mixers. They mix them up. And one, it can be really scary because sometimes it blows up. And then they pour it into these molds and they let it cure for several days or weeks. And this requires dozens of engineers to watch over this. What Firehawk has figured out is if you use the right combination of chemicals, all you need is not even a $200,000 printer. That's what we use, but $100,000 printer. We've printed it out of a $10,000 printer. The idea is you can use a commercial off-the-shelf printer so you can produce rocket fuel with a storable feedstock, because that's actually the other important thing. When you mix that propellant, you have to immediately, typically, the old school way, pour it into a mold and let it cure. But with ours, when we make our feedstock, you can store it for long periods of time and then use any printer in the world to start printing that fuel grain. But you don't need dozens of engineers to do it. My guy is a guy named Ben G, or Ben Giles. I call him Ben G. He's always in a Baylor Bears polo. He just presses a button and he starts printing. And usually I have a slide that showcases this, but it's going to be a little sloppy and you might not understand it, but I'm going to try anyways. Imagine an X and Y axis when you're producing rocket fuel and you're pouring it into these molds. You usually have a little bit of downtime and then it goes up. And this is like your max capacity to produce the fuel. And then it's cured. You take it out, your fuel is done. And then you have to remove it and then you have to mix it again. And then it goes back up again. And that's max capacity for producing fuel. But with a Firehawk printer, we're just constantly printing up here. So we just have a constant volume of printing, and we just have dozens of these printers. Well, we don't have dozens of these printers yet because we don't need that, but we have two printers that can produce thousands and thousands of fuel grains a year. And so one of the really neat things about this is we can print on the edge. So one of our programs is why we're printing out in the desert is, we want to start cutting that supply chain from having to just produce in, Camden, Arkansas or Utah and start, being an island or two away from the action, being on the edge, getting a Connex box with a propellant factory to Taiwan, to Guam, honestly, even over to Italy, just closer to where our allies are, to the users of this end product. So Firehawk's found a fair amount of success with this new decentralization of our product, working with these folks who are interested in spreading our resources. We actually had someone, a congressman, who's like, can you put this on a football field in Biloxi, Mississippi? And the answer is yes. We're not going to do it unless it's a cleared out high school, but the answer is yes. Like, we can start putting our facilities all around the country so we don't just have two locations. Um, but the idea is that with the Firehawk technology, you don't need a $500 million facility to produce rocket fuel, which is a huge problem. Because if you look at the industry today, just what we gave away in 2 years to Ukraine, it's going to take us about 8.5 to 9 years to resupply. And that's really if like Aerojet, Orbital ATK, and all the big dogs are producing at their surge capacity. So it's it's a big problem, but we've been able to raise just under $30 million to try to solve it. We've gone after appropriations really hard. We've hit 8 figures in contracts, $10 million plus in appropriations to work with the Air Force, work with the Army. We have phase 3 SBIRs, so we're starting to get that support right now, and that's one of the benefits of getting to do this in the United States is they're really hungry to support. I know I was that guy at that table who mentioned Taiwan in 2027. That is something that should happen. One of the wild things that I heard is we're looking at like 40 or 60 billion-dollar plus ups that are going to happen for Ukraine and for other countries. Something really bad happens overseas in the Pacific, we're talking more like 500 plus billion-dollar plus ups. It's going to get really interesting, and our industrial base has to be prepared for that. And that's not just the primes who do provide the best technologies in the world, but like I think Andrew said, they're not going to innovate themselves out of business. They're going to be dependent on new companies to come in and provide that innovation that they can use. So we need companies like ourselves, like Firehawk, like Firestorm, to build technologies that can supplement them and be a part of those plus ups and help our allies who are going to need it. So yeah, so we're Firehawk. We 3D print rocket fuel. I have plenty of this in my backpack. If you guys want to come see it, just let me know. So thank you.